We're going to talk about solving polynomial inequalities using two different methods. The first method that we're going to focus on in this video is solving a polynomial inequality graphically. So if I have the inequality that's given here, x plus 3 times x minus 1 squared greater than 0. And you can see that I am given the graph down here. This is the graph represented by that function. Well, when I want to solve the inequality, I am actually looking for values of the inequality that if I were to plug them into the equation would make this left side greater than 0, or in other words, we would make it a true statement. Think when you're talking about an inequality, you want to remember that as opposed to an equation, when I solve an equation, most of the time I get just one simple value that makes the left equal to the right. When we think about inequalities, we're actually looking for a range of numbers that satisfy the question, so to speak. So for this inequality, we already have it factored, don't we? And we know that we are crossing the x-axis at -3, and we are touching the x-axis at +1. Now, if I want to ask you, where is the function greater than 0? I'm basically asking you, where is the function above the x-axis? So I'm looking at the picture down here, and I can say, well, I am above the x-axis here within this section, and then again I am above the x-axis over here on that section. One of the things again that you also want to remember is because I have this symbol here, I am greater than but not equal to 0, then I am greater than 0 between -3 and +1, but then I'm also greater than 0 from 1 all the way to infinity. Now I cannot include the number 1 in my inequality solution because that would imply that I am equal to 0. Okay, so if we're just greater than, then we cannot include these values that actually are sitting on the x-axis. So the solution to this inequality is from -3 to 1 union 1 to infinity. So if I wanted to just look at the graph, that's how I would solve it. Now, since we're still looking at this picture, I'm going to get rid of these values for just a second. And hypothetically, what if I wanted to know where is the function? This time I want to know where is it less than 0? Where is my function less than 0? Well, less than 0 is only occurring on this portion of the function here, right? So if I'm coming from -infinity all the way up to -3, those would be the value, the x values of my function that would cause it to be less than 0. So for my function to be less than 0, that solution would look like -infinity to -3, and that's it, because there's nowhere else on the function that is below the x-axis. So that's how we can use a graph to be able to solve our polynomial inequality.